All right, welcome to video 2, maybe shorter than video 1, should be anyway. So for video 2, we're just going to do some more some graphical stuff. Okay, so for this first one, what I want you to do is sketch. It'll be example 2 actually. It's sketch the line with the following things. Okay. So sketch a line with slope equals negative 2/3, and the point 1, 2 is on the line. All right, so this is where if you have graph paper, you're going to want to bring it out. You don't need graph paper for this class, but it will be helpful, okay? So just whether you have or don't have graph paper, you're still going to do it the same way. You're going to make your little graph. If you don't have graph paper, I will need you to like actually show me your scale if you don't have graph paper. All right. But if you do have graph paper, then something like this is enough. So the point 1, 2, remember 1 is the x coordinate, 2 is the y coordinate. So that's where that point looks like right here. And then remember negative, this is rise over run, remember? And the negative means that you go down. So you go down 2 and then right 3. That's going to bring you right there, okay? And then down 2 more, right 3 more again. And again, consequently, you can go the other way, right? You can go up 2 and left 3. Is going to bring you over here. You don't need 4 points, but adding points is usually a good idea, but you only need technically 2. But the more points you graph, the better the chance is going to be. And then you just connect the dots. Which is easier said than done for me, but not my worst line. Not the worst line I've ever drawn. In this class, you're going to see some interesting graphs from me, but this isn't the worst one. And that's all there is to it. Okay. Negative just means we're going down, right? It's like if there's kind of a, if there's a person on a little bicycle over here, let's say negative just means the person on the bike is going downhill. All right. That is beautiful. Whereas if it's positive, the person is biking uphill. All right. So that's all there is for example 2. We did it. Okay. Let's move on to the next one. All right. So example 3 is, what is the equation or find an equation for the following? All right. That's supposed to be a colon. And here I will give you a graph and you have to find the equation. All right, this graph goes through this point, this point. And it's connected like this. So to find an equation, right, you have to know the slope, you have to know the point, or you could use the slope and the y-intercept. Here, it's kind of hard to find the y-intercept here though. Right? Like, it's not obvious. Y-intercept is what? Who knows? But we do know these 3 points right here. So we're going to find the slope. We're going to find a point. We're going to use point slope form. Here we go. All right. So the slope, remember, is going to be rise over run. So you pick 2 different points. This is the point 1, 1. This is the point 3, 2. If you want. So subtract the y's, 2 minus 1, subtract the x's, 3 minus 1. Remember, rise over run here. That's going to give us, whoa, something bizarre. That's going to give us 1 over 2. That is our slope. Our slope is 1/2. And then we're just going to choose a point. All right, so let's let this guy over here be our x1, y1. And we'll just plug it into point slope form. Y minus y1, which is 1, is equal to our slope, 1/2, times x minus x1, which is also 1. And this is a perfectly good, acceptable final answer. If you did a couple of other steps and put this in a slope-intercept, you would get y is equal to 1/2 x plus 1/2. This is also a good answer. I'll take either one, but you don't need to do more work than what's boxed up there. Okay? And that's how you do example 3. All right, 2 more examples for this video. The next 2 are kind of weird, all right? So you may be coming into this video just because you saw these next 2 examples and said, these examples are weird. All right, so this is going to be example 4. It's going to be a little bit more in depth. For a line with slope m, if you begin on the line and move h units in the x direction, how many units do you need to move in the y direction? All right, so kind of a tricky question. Let's unpack this and try to figure it out, okay? So the first problem is going to be part A, where our slope is equal to 2 and h is equal to, you begin on the line, I think I forgot that word. You begin on the line and move h units in the x direction. How many units do you need to move in the y direction? All right, and here, h is going to be 1/2. So our slope is 2. And remember what a slope of 2 means, right? That means that if we go over 1, we're going to go up 2, right? That's what m equals 2 means. But here, it's not asking us, are we going over 1? It says, if we're moving h units in the x direction. So now we're not moving over 1, we're moving over 1/2. Okay, so in our case, we're going to move over 1/2. We're going to move half the distance in the x direction. It means it's only half the distance in the y direction. So if we move right 1 unit, we go up 2. If we move right 1/2 of a unit, we only go up 1/2 of that, which is 1 unit. Okay, so our answer is just going to be up 1 unit. And these problems are going to be very important when we start getting into derivatives and approximations, okay? Finding approximations with tangent lines, finding approximate marginal cost for the business applications. These ones are going to be very important going on. So if you don't get them, get them, okay? It's important, all right? And ask me questions about this. So what about if the slope was 8? Okay. And we moved over 3 units. So again, this one can't really draw it that well, but we know the slope being 8, right? 8 is 8/1. So if we move right 1 unit, we're going to have to move up 8. But again, what this problem is really asking you is what happens if we move right 3 units? Well, if you move right 3 units, and I know it's getting cut off a little bit, you're going to need to go way higher, right? If you move right 3 units, you're going to have to go 3 times as high, which is going to be 24. Okay. You'll have to go up 24 units here. And that's how you approach these problems. We'll do one more for good measure and then move on to the last type of example. All right. What about a slope 3 and we go right 2/3 of a unit? Again, slope of 3, what does that mean? It means that if you go right 1 unit, you have to go up 3. Well, h 2/3 means how much do we go if we only go 2/3 to the right? How high are we going to have to go? The answer is, well, if this is 2/3 of that, you couldn't see that. If this is 2/3 of that, well, then this has to be 2/3 of that. Okay. This is like similar triangles. Okay. So the answer is going to be 2/3 times 3, which is just 2. All right. That's how you approach these problems. Again, please ask me if you're confused about these because they are very important. They are going to come back again. All right. All right. Last example. It's very, very similar. Okay. The last example is going to be example 5. What this one says is if a line has slope -3 and the point 2, 2 is on the line, fill in the following. And I realize that this looks a little strange. We'll fix it. Fix this right here. Much better. Great. Let's see what it looks like. So you have to fill in the blank here. 3, something, 4, something, and 1, something. So this is very similar. Okay. So we know the point 2, 2 is on the line. How do we get to x is 3? Okay, so 2, 2 on the line. To get x equals 3, right? That's moving right 1 unit. Well, if we move right 1 unit, what's our vertical change? The slope is -3, right? The right 1 means down 3. So what's down 3? Down 3 from -2 or from +2, well, 2 minus 3 is equal to -1. So that's our answer for this first one. And then notice, right, we have to go over to 4 as well. Again, that's right 1 unit. We have to go down 3. So again, we say, okay, well, what's down 3 from -1? Well, that's -1 minus 3, which is -4. That's, hold on. That's -1 minus 3, which is -4. And you can even see it now. How about that? So the y-coordinate here is going to be -4. Be careful on this last ordered pair, though. That's 1. We're not continuing on with this pattern, right? So to get to 1, right, to get to x equals 1, we need to move this last one, right? It's going to be left 1 unit, which means because the slope is -3, if we're going left, that means it's going to be up 3 to get to this last one. This is going to be the point 1, 5. All right. And if here, let's be real mathematical superstars. Right. So it's -1. That's the work that we did in blue. -4, that's the work we did in green. And it's +5, that's work we did in yellow. I love colors. All right. And that's kind of these problems. If you have any questions, let me know. Otherwise, get working on this problem set, and then you'll watch the final video to do the final problems. Good luck.